Hi, this is Krista Velasco, and I'm here working with Giovanni, and we're working on simple and fractional distillation.
The purpose of this lab is to separate two solutions, which in this case were ethanol and water, and we will be using their different boiling points, and we're going to heat them to evaporate the one that's more volatile first, and then try to figure out the concentration of that liquid in the mixture. For simple and fractional distillation, we use two similar apparatuses with one major difference, which is the columns at the top of the evaporating flasks. You see on simple distillation we have a flask that has a short column and it's attached to the water jacketed condenser to give us the distillate. For fractional distillation we have the same flask but with a longer column, and that column is filled with several beads, and those beads we're going to explain what they're for right now. In simple distillation, we expect less purity of the distillate, and it's a one-step distillation process, while in fractional distillation, we are going to do several small distillations, I guess you can call them, inside the column. That's what the beads are there for, and we expect a higher purity of the distillate.
As said in the previous slide, regarding the glass beads in the distillation column, in the fractional distillation apparatus, the main point of using the glass beads is to allow the liquid inside to condense and evaporate and condense once again, so the liquid is distilled many times. The main theory to fractional distillation is that the more times it is distilled, the more pure it is, which is the main purpose of distillation, to separate and purify a compound.
So water and alcohol have different boiling points. As you can see, ethanol, the alcohol that we're using, has a boiling point of 78 degrees Celsius, while water has 100 degrees Celsius. In the mixture, we expect the ethanol to lower the boiling point, or the boiling temperature of water. So as you start distillation, there will be a mixture in the vapor of ethanol and water. But in fractional distillation, for every time it condenses on one of the beads, it'll be a more pure ethanol distillate. And by using these different temperatures at which they evaporate is how we are going to separate ethanol from water. We expect ethanol to evaporate earlier than water because of this temperature. So whenever the temperature reaches around 78 degrees, we expect the vapor and the distillate going into the graduated cylinder to be ethanol.
There is a limit to the purity of the distillate because it becomes an azeotrope at 92% of ethanol. This happens because when the vapor phase has the same concentration as its liquid phase, it in turn would prevent separation. So the liquid boils at this temperature and then turns into vapor, which has a higher concentration of purity, and condenses once again, boils at this temperature, and vaporizes once again. At each step that it condenses and then vaporizes, it becomes more and more pure until it gets to 92% ethanol, which will then in turn be the most pure it can be because an azeotrope was reached.
So what volatility explains about a molecule is its reactiveness when it comes to being out in the air, out in the open. So how much it evaporates, how easy it evaporates. The ethanol that we're using is connected by intermolecular forces known as London forces. As you can see here, the carbons, create this ethanol molecule creates these bonds, intermolecular bonds with these carbons on this ethanol molecule, whereas in the water molecules we have bonds known as H bonds, which we know are stronger. The O is more electronegative than the hydrogen, So we have hydrogens bonding with the O's, creating an intermolecular force with the oxygens in the opposite water molecule, while the hydrogens on this one bond with this oxygen here, or create an intermolecular force with this O in this water molecule. So in turn, what we have is a stronger bond here and a weaker bond here. So when you have that, this becomes more volatile or easier to separate, which is why it has a lower boiling point. Whereas this one, these water molecules have an intermolecular force of hydrogen bonding, which is stronger and therefore requires more energy to break apart, hence the higher boiling point. So the physical changes that boiling them creates is simply a change in phase. So this goes from a liquid to a gas, and this will also go from a liquid to a gas, but ethanol will break sooner, so it'll turn into a gas quicker than water will.
To conclude this presentation, the required properties for distillation would be that there would be at least 2 liquids, that the liquids have different temperatures or different boiling temperatures that need to be at least 30 to 40 degrees different or in between each other, and that both liquids be miscible with each other.